I want to show you something that made me stop scrolling when I first noticed it. Zoom into a map of the Mojave Desert, and there's a roughly 40-mile stretch of California that has lit up with earthquake swarms 3 separate times since the beginning of this summer. Not 3 earthquakes. 3 swarms, meaning 3 separate bursts of dozens of quakes clustering in the exact same corridor. And according to the scientists who actually track this specific patch of ground, this is already the 3rd instance of that kind of activity there since January. Same neighborhood, again and again. And it's happening right next to a fault that researchers have openly said could produce something in the magnitude 7 range, if it ever lets go. So I wanted to actually dig into this properly, instead of just reacting to the headline, walk through what's been shaking this stretch of desert, why it keeps happening in the same place, and whether, not normal, is actually the right rate on it, or whether there's a calmer, more grounded explanation underneath. Subscribe if this kind of deep dive is useful to you, because this corridor has genuinely earned a closer look. Let's get into it. First, the geography, because it's really the whole key to understanding everything else here. We're talking about the Eastern California Shear Zone, a wide, seismically restless band of desert running through the Mojave, sitting just north of a structure called the Garlock Fault. Unlike the more famous San Andreas, which slides right lateral, the Garlock is left lateral, and it marks the southern edge of the larger basin and range geological province. Researchers studying stress on this fault haven't minced words about what it's capable of. If a heavily loaded stretch of it ruptured, they've said, it could generate an earthquake somewhere between magnitude 6.7 and 7.0. For context, that's roughly the scale of what hit this exact region back in July 2019, when a magnitude 6.4 foreshock near Ridgecrest was followed a day later by a magnitude 7.1 main shock, the strongest earthquake to hit Southern California in 2 decades. That 2019 sequence isn't just background trivia here, it's genuinely the thread connecting everything that's happened in this corridor since. When that magnitude 7.1 ruptured, the shaking itself was only part of the story. It fundamentally rearranged the stress sitting on the surrounding network of faults. Researchers who went back and modeled the aftermath found that the Ridgecrest rupture increased stress on the neighboring Garlock Fault by roughly 30%, and it set off thousands of aftershocks rippling across nearby faults in the months and years that followed. Scientists describe the ground in this region as still actively working through that stress redistribution, something geologists sometimes call crustal readjustment, and it's a process that can genuinely take years, sometimes decades, to fully settle. So let's actually walk through what's happened this summer specifically, because laid out in order, the pattern is honestly pretty striking. On the afternoon of July 13th, a fresh swarm kicked off about 17 kilometers southwest of the small desert town of Johannesburg, sitting right in that same shear zone corridor. It started quiet, with a minor magnitude 1.5 tremor at shallow depth. But after several hours of relative calm, things picked up sharply. A magnitude 4.3 quake struck in the late afternoon, strong enough to be felt across surrounding communities, and it kicked off a wave of follow-up tremors, more than a dozen additional quakes in the following hour alone. Over roughly 11 hours total, that swarm produced 28 separate earthquakes. And according to researchers tracking the longer arc of activity in this exact patch of desert, that Johannesburg swarm was actually already the 2nd identified swarm in this specific area for 2026 alone, part of a broader trend that's clearly accelerated since 2019. Go back to the year 2000, and researchers count only 2 distinct swarms here across an 18-year stretch, one in 2009, one in 2016. Since Ridgecrest in 2019, that number has jumped to 6, including 2 in 2019 itself, 2 more in 2025, and now this year's activity stacked on top. Then, just over 5 weeks later, on August 21st, a new sequence rattled the Coso Volcanic Field, sitting just north of the Garlock, roughly 100 miles northeast of Bakersfield. USGS recorded 7 separate tremors near Coso Junction by that Friday afternoon, the strongest coming in at magnitude 3.4. Coso isn't your typical patch of desert either. It's not one mountain or one fault line. It's a genuinely strange 150 square mile cluster of volcanic features, dozens of vents and domes sitting above a large underground zone of magma with active geothermal fields, fumaroles, and hot springs dotting the surface. That combination, live magma at depth paired with a dense network of surface fractures, is exactly the kind of setting that produces swarms instead of a single dominant main shock with a fading tail of aftershocks. Instead of strain building up and releasing all at once along one clean fault plane, pressure and fluid move through a whole tangle of smaller interconnected cracks, letting energy out in bursts rather than one big release. So there it is, laid out plainly. 2 clearly documented swarms about 5 weeks apart. both sitting in the same broader Eastern California Shear Zone and Garlock corridor, both in a region its own seismologists already classify as still working through 2019's stress redistribution, and both arriving on top of what researchers had already flagged as the second identified swarm cluster in that exact area for the year. That's the honest basis for calling this 3 swarms in 2 months. Whether you draw the boundary lines at 2 events or 3, depending on exactly how you count, the underlying trend holds up either way. Activity in this specific stretch of desert has been arriving in tight, repeated bursts, noticeably more often than this region's historical baseline would predict. Now here's where I want to slow down and actually be careful, because not normal and dangerous aren't automatically the same thing, and I think a lot of coverage of stories like this blurs that line without meaning to. Earthquake swarms are a well-documented, genuinely well-understood phenomenon, and they behave completely differently from the main shock-aftershock sequences most people picture when they imagine a dangerous earthquake pattern. In a main shock-aftershock sequence, one big quake hits first, then a long tail of progressively smaller aftershocks follows, fading out in a fairly predictable curve over days or weeks. A swarm just doesn't work that way. Instead of one dominant event, you get a cluster of quakes of roughly similar size, arriving in bursts and waves, sometimes going quiet for hours before picking back up, never really building toward one clearly largest quake. That's exactly the shape both the Johannesburg and Coso sequences followed this summer, and it's the same shape seismologists have documented repeatedly in this exact corridor for decades. And this is the part I think matters most. When the USGS's California Volcano Observatory specifically investigated a comparable swarm in this same Coso region, their conclusion was direct. They determined the activity was tectonic, tied to ongoing stress adjustment, not volcanic unrest, and found no ground deformation consistent with magma actually moving toward the surface, meaning no imminent eruption threat despite Coso's genuinely active volcanic underpinnings. That distinction is a big deal because it tells you these swarms are being driven by the region's fault network continuing to redistribute. Stress inherited from 2019, working through countless small, often previously unmapped fractures, rather than magma pushing upward. It's essentially the crust finding new, smaller ways to bleed off energy that's still sitting there from an earthquake 7 years in the past, not any single fault building toward an imminent, larger failure. It's actually worth understanding how seismologists tell a routine tectonic swarm apart from one that might be pointing toward something more volcanic, because the method is less mysterious than it sounds. 2 main things get checked. First, location relative to known volcanic features, and Coso genuinely does sit near real, if long dormant volcanic vents and domes, which is exactly why any swarm there earns extra scrutiny compared to one somewhere with no volcanic history nearby. Second, and more tellingly, the actual pattern of quakes over time. Tectonic swarms driven by fault stress redistribution tend to taper off within days to a couple weeks, generally without the kind of slow, sustained surface deformation that GPS instruments would pick up if magma were actually rising. Volcanic swarms, by contrast, usually compared with exactly that kind of measurable ground movement, along with shifts in gas emissions at nearby vents or hot springs. Neither the Johannesburg nor the Coso sequence this summer showed any of those volcanic warning signs, which is precisely why researchers classified both as tectonic, consistent with the broader stress adjustment story that's been running through this whole corridor since 2019. It's also worth remembering that this isn't the only corner of California that behaves this way, since it puts the Mojave activity in a wider frame. The Salton Sea region, especially the Brawley, seismic zone south of it, has its own long, well-documented history of exactly this kind of swarm behavior, including a 2020 sequence researchers eventually traced to what's called a slow slip event, essentially a fault creeping in a way too gradual to register as a normal earthquake, but fast enough to trigger hundreds of small quakes as a side effect. And up in the Bay Area, San Ramon has produced its own recurring swarms for decades, tied to the Calaveras fault system, with documented clusters going back to the 1970s. The point isn't that all of these places are secretly connected or building toward the same event. It's that California's crust, broadly speaking, tends to release stress through exactly this kind of clustered, bursty activity in specific, well-mapped corridors, rather than spreading it out evenly across the state. The Eastern California Shear Zone happens to be one of those corridors, and 2019 gave it an unusually large amount of extra stress to work through. That said, I don't want to wave away the Garlock concern entirely, because it's a legitimate piece of context and deserves honest treatment rather than a dismissal. The Garlock hasn't produced a large earthquake since instrumental recording began in this region, roughly a century of data now, but there's genuine geologic evidence in the rock record that it has ruptured significantly further in the past. Researchers describe it as having been quiet for a long stretch, but they're clear that quiet doesn't mean incapable. It's precisely because the Garlock demonstrably absorbed a real stress bump from the 2019 Ridgecrest sequence that scientists have kept such a close eye on this whole corridor since, and every subsequent swarm gets evaluated at least partly through that lens, not because any individual swarm is expected to directly trigger the Garlock, but because understanding how the surrounding crust keeps behaving helps researchers refine their picture of how much stress that fault is actually carrying at any given moment. I think it's equally worth being upfront about what these repeated swarms don't tell us, because that matters just as much. There's no established scientific method for using a swarm like Johannesburg or Coso to predict exactly when, or even whether, the Garlock will eventually rupture. Earthquake prediction at that level of specificity just isn't something seismology can deliver right now for this fault or any other on the planet. What these swarms actually provide is data, a genuinely large and growing amount of it. Every swarm that lights up in this corridor gets folded into an increasingly detailed picture of how the Eastern California Shear Zone's dense web of small, often unmapped faults keeps responding to the massive stress shift from 2019. That's real, valuable scientific work, even though it doesn't come wrapped in a tidy, reassuring forecast. It's also worth putting this summer's activity next to what an ordinary California earthquake year even looks like, because the state logs thousands of small quakes annually, the vast majority under magnitude 3 and never felt by anyone at all. What makes a pattern like this one stand out isn't the mere existence of small earthquakes. That's just background noise for California geology. It's the clustering, both in space and in time. 3 distinct bursts, all landing within roughly the same 40-mile stretch of desert, all inside about 2 months, is a meaningfully different statistical picture than the same total number of quakes scattered randomly across the state over that same window. That clustering is exactly why seismologists treat this corridor differently from the statewide baseline, and why a swarm here draws tighter scientific attention than a similarly sized one might somewhere with a quieter recent history. It's worth noting how local and state agencies actually respond to a pattern like this too, because the response itself tells you something about how seriously and how calmly professionals treat elevated activity like this. California's Office of Emergency Services has a well-worn playbook for earthquake swarms, refined over decades of dealing with exactly this kind of cluster activity in places like the Brawley Seismic Zone near the Salton Sea, another part of the state notorious for producing hundreds of small quakes in a matter of days. That playbook doesn't involve evacuation orders or road closures based on swarm activity alone. It typically means public awareness messaging, reminders to enable earthquake alert apps, and close coordination with USGS scientists, watching for any sign the pattern is shifting from routine swarm behavior into something that resembles the buildup to a larger event. Neither the Johannesburg nor the Coso swarm triggered anything beyond that standard level of monitoring and messaging, and that itself is informative, since agencies with access to the full seismic dataset, not just the headline magnitude numbers, didn't see anything in either sequence that called for a more urgent response. So what does this actually mean if you live in or near this stretch of desert in towns like Ridgecrest, Trona, Johannesburg, or the communities scattered around Coso? Honestly, the practical guidance doesn't change much based on any single swarm, because the underlying seismic hazard in this corridor has been elevated since 2019, regardless of which particular week a new cluster happens to show up. Keep your phone's earthquake early warning features turned on, since California's shake alert system can give you precious seconds of notice before shaking arrives, genuinely enough time to drop, cover, and hold on before the worst hits. Secure heavy furniture and shelving so it can't tip during stronger shaking, and keep a basic emergency kit with water, a flashlight, and a first aid kit somewhere you can actually grab quickly, not buried in a closet you haven't opened in years. None of that is specific to this particular swarm. It's just sound practice for anyone living somewhere seismologists have explicitly flagged as still working through the after effects of one of the largest earthquakes to hit Southern California in decades. I think what actually makes this story worth understanding, instead of just reacting to the headline version, comes down to the difference between frequency and danger. 3 swarms lighting up the same corridor in 2 months is, by this region's own historical baseline, a meaningfully elevated rate of activity, and calling that unusual is fair. But unusual frequency in a well-understood tectonic setting, driven by a documented, explainable mechanism, ground still redistributing stress from a known 2019 rupture, is a fundamentally different story than an unexplained acceleration with no clear cause behind it. Scientists aren't looking at this and shrugging it off as meaningless. They're actively studying it, precisely because a corridor that keeps producing swarms is a corridor worth understanding in real detail. But they're also not treating it as a countdown clock toward an imminent Garlock rupture, because that's simply not what the current science actually supports. Before I wrap up, I want to hear from you. If you live anywhere near the Eastern California Shear Zone, the Ridgecrest area, or the broader Mojave, have you actually felt any of this summer's swarm activity? And did it feel any different from the region's typical background seismicity? And does knowing that these swarms are a documented, explainable response to 2019's stress redistribution, rather than some mysterious new threat, change how you think about the risk here? Or does the Garlock's magnitude 7 potential still weigh on you regardless? Drop your thoughts in the comments, because I always find it genuinely interesting how differently people process this kind of ongoing, elevated seismic activity, depending on how close they actually live to it. If this breakdown helped you understand the real science behind a pattern that genuinely sounds alarming in a headline, do me a favor and hit that like button, because it helps this kind of grounded, research-based explanation reach more people instead of the panic-driven version. Subscribe if you want to stay on top of what happens next in this corridor, because given how active this stretch of desert has been all year, I really don't think we've seen the last swarm out of it. And as always, drop your thoughts below, because this community consistently brings perspectives and local knowledge I genuinely wouldn't get anywhere else.